In this lecture, we're going to make our workers return their supplies back to the nearest command post after they've gathered some minerals or gas. If we quickly take a look at our behavior tree, in the previous lecture, we added this variable here about the amount of supplies, but we didn't use that yet. This is like an output parameter, and there's kind of two ways we can approach these. We can have them in the story like this so we can easily drag variables there, or we can make them where they're kind of hidden, like what we saw on the default movement node, where on the default movement node, we have these things like the speed, distance, animator speed param, and slowdown distance that are all available. We can hook up stuff from our Blackboard over there, but they don't show up in the story. That's a cool feature because sometimes if you need too many variables hooked up in the story, it becomes very verbose and doesn't really say what's happening anymore because you just have to hook up everything in this really long line of text. For the concept of returning resources, once we've gathered some supplies, we're going to want to initiate a new action that's going to be moving back to our nearest command post. So we need to find that command post, move to it, and then we're going to want to take this amount and use it in a future action. So we can obtain those supplies and increase the amount that the player has. Again, we're not going to do all of that in this lecture, but that's where we're going to. So we're going to need an integer, the amount that we gathered, because remember, it might not be whatever's on our gatherable supply. It could be less than the default config. Let's add a basic type, integer, supply amount held. And let's hook that up there on our story. The next thing we need to do is identify the nearest command post and then move to it. It sounds like we need a new action to find the command post, and we're going to need to store that in the Blackboard. Then we're going to move to that location. So that sounds like two new nodes, one to find the command post and one to move to a target game object, because right now we're only moving to a target vector 3. Let's go ahead and create a new action by right-clicking, create new action. And we'll call this find closest command post. And that's going to be under actions, units. Since we've created this now and we have at least one action there, the behavior system knows about it and we don't have to type it custom each time. Let's click next, and in the story, we can type unit finds nearest command post, where unit's going to be a game object. And we can see it incorrectly classified our command post as unit commands because we have a Blackboard variable called command. This is also going to be a game object. Let's go ahead and create that. Again, put that in our script's behavior. Before we get into VS Code, let's make our second action here about moving to a target game object. Let's right-click, create new action. We'll call this one move to target game object. And this one will be under actions navigation. Agent moves to target game object, where the agent will be a game object and target game object will also be a game object. We can go ahead and click create. Again, scripts, behavior, save it there. And now we'll hop into VS Code. In our gather supplies action, for this amount to really be an output variable, whenever we're getting this end gather return value of amount gathered, instead of assigning it to this local variable that's not doing anything, we should assign that Blackboard value, the amount.value, to be the result of gatherable supplies.value.endGather. Now, whenever we end that gather, we're going to post a new value to the Blackboard for whatever is assigned to that amount. Let's move on to find closest command post action. We're going to put that in our GameDevTV RTS behavior namespace. And how do you think we can find the closest command post? There's several ways we can approach this with varying complexities. I think for now, what we can do is say that we'll use the physics system by doing a physics.overlapSphere at our current units location to find any buildings nearby and see if any of them are the command post. And then from there, we can say which one's the closest. In a typical gameplay scenario, there's not going to be a ton of nearby buildings around the units, around the minerals, so this shouldn't be too bad. But what that does mean is we're going to need some additional stuff here for this action, and that's where we're going to get into showing some of those hidden, in air quotes, variables. Let's say that we want to configure the search radius, but we don't want to show that in the story. We can do a serialized reference, public Blackboard variable of type float, called search radius and set that to be a new Blackboard variable with the default value of 10. We don't need anything on update or on end. And on start, we're going to want to do our physics overlap sphere. Let's define a collider array of colliders equals physics.overlapSphere. We need to start from our unit's current position. So we can do unit.value.transform.position and the radius will be our search radius. But remember, we want to only check on the buildings layer. We don't want to get a bunch of noise here from getting other units and all that kind of stuff. And we do that with the layer mask. So we can do layer mask.getMask and do buildings. Now this will give us all of the colliders for the buildings that are within that search radius. We want to filter out any of those that are not the command post. And in order to tell which one is a command post, we need some way to determine that, right? Because right now we only have a base building, but that base building has a reference to our unit SO. We can add a new Blackboard variable then with a serialized reference, public Blackboard variable unit SO command post building. Back in onStart, let's make a list of base buildings called nearby command posts and just initialize that to be a new empty list. We can then iterate over each of those colliders with for each collider in colliders and check if that collider has a base building with if collider.tryGetComponent out base building. That'll return true only if that building is there. So we can do and building.unitSO, which is currently private, but that's okay. We're going to fix that in just a minute. We can see there is a need to be able to retrieve this from other classes. We'll check if that's equal to command post building.value. And if that's true, then we know this is a command post and we can add it to our nearby command posts list. Just outside that for each, if the nearby command post count is equal to 0, then we can return status failure, meaning we cannot proceed because there's no nearby command post. Otherwise, we can set the command post value to be, let's just say, the first nearby command post. We can do some more sophisticated logic here later. Let's keep it simple for now. So nearby command posts indexed by 0.gameObject. Then we'll return that success status. Now let's take care of this compiler error by going to our abstract commandable. We've got a serialized field, private unit SO, but now we can see that we need it to be public with a public get in a private set. We don't want anybody messing with this. So we can change it to be a public unit SO with a field serialized field and a public get in a private set. Now our find closest command post action should find us the closest command post and then return success if there's one nearby. We had one other script moved to target game object action. And for this action, it's actually going to be this lecture's challenge. Implement that move to target game object action so the agent moves to the target game object's position. Pause the video if you need to refer to how do we move to a target location and get this move to target game object working correctly. And once you've got that, I'll see you right back here. All right, welcome back. Let's jump right into VS Code. First things first, we'll put it in our GameDevTV RTS behavior namespace. We'll define a class member variable, private navmeshAgent agent. In onStart, we can say if not agent.value.tryGetComponent out agent. Return status failure in that case, meaning that there's no navmeshAgent on our agent game object. That's probably a configuration error and we can't proceed. Then we'll check if the vector3 distance between the agent transform position and the target game object value transform position is less than or equal to the agent stopping distance, or return status.success. That means we're close enough to the target, we don't need to do anything. Otherwise, we'll set the agent destination to the target game object value transform position and return status.running. Target game object.value.transform.position is a very long piece of text. So what we can do is define a vector3 target position, set that equal to target game object value transform position, and replace that really long piece with just target position to make everything a little bit shorter. Then of course on update, if the agent remaining distance is less than or equal to the agent stopping distance, we'll return success. Otherwise we'll return running. And we can remove on end, there's nothing to do there. If you were to pull up the move to target location action, you'll see that this is almost the exact same, especially after this little refactor. We're just grabbing the target position off the game object. Now let's come back into Unity. We should be almost done. After we've gathered some supply, we want to find the nearest command post, and we want to move to that command post. Let's stack those in our sequence with finding the command post and then moving to that target game object. And we need now a Blackboard variable for a game object for this command post. Let's just call it command post. Drag that to both of those references there. Drag self for the agent and the unit. But remember that top one self finds nearest command post, we need to attach our scriptable object in our inspector. If we click the link icon there, we can see that we need to create a new unit SO on our Blackboard. Let's do that and call it the command post SO. And we can define the default value right here, command post, so we don't ever have to set that value. We've just given it the default value there, so it's always going to be right. Now let's come into the scene view. Let's move our command post a little bit closer to the minerals. The exact location isn't really important. Move the couple units that would be spawned inside of there out of the way. And before we can click play, we need to go to Units, Worker, find that worker, and we have to rehook up our unit SO, probably on all of our units because we've changed this from a normal private serialized field to a field serialized field. That makes it lose that reference. And we'll hook up our command post as well. On our supply hut, we can hook up that unit SO as well. Same for our air transport. And we also have our barracks, which we haven't applied to the prefab yet, but that's also missing the unit SO. Let's attach that and go ahead and apply the base building to that barracks prefab. Looks like the decal projector as well. Let's go ahead and just apply it all to the prefab. Then we can select a worker, click play. If we select one worker, ideally the one we have selected in the hierarchy, come down here and click gather. Click on one of those minerals. We'll see the workers coming over here. In the Blackboard, we can see they're getting the gather command. They'll stand here for a second, gather the minerals, and we can see that the supply amount has now set up to be 8. They've got the command post prefab, and now they're heading back to that command post. Now they're moving back and forth between that same mineral that they were gathering and the command post. So that's looking pretty good for basic gathering. But there are a few problems here. One is typically when units are gathering, they don't try to avoid each other. Just makes it a lot less smooth, as we can see here. 2, whenever they are returning those minerals, we're not seeing our minerals change. So we don't see anything on the UI, and we don't really have the concept of the minerals or the supplies that we have yet. And we don't really have any animations hooked up. The worker here is just sliding around and standing next to the minerals. We'll be addressing these one at a time in the next few lectures. So when you're ready, I'll see you on the next one.